Welcome. In this video, we are going to take a look at problem 49. It is from chapter 19 of College Physics 2E by OpenStax. In this problem, we need to calculate the voltage that is applied to a 2.00 microfarad capacitor when it holds 3.10 microcoulombs of charge. Okay, let's start with what we know. Okay, we know the capacitance is 2.00 microfarads. We know the charge Q is 3.10 microcoulombs. And we need to find the voltage that's applied. Note, this is a potential difference. It's customary to use V instead of delta V. All right, so our starting equation is that the charge is equal to the voltage times the capacitance. So we need to solve for V. We'll divide both sides by C. And so we'll get V is the charge divided by capacitance. We can substitute the numbers. Charge Q is 3.10 microcoulombs, and we will convert that. In 1 coulomb, there are 10 to the 6 microcoulombs. Okay, we need to divide by capacitance, 2.00 microfarads. We'll convert that one. 1 farad is 10 to the 6 microfarads. So we can see converting both to micros just cancels out. So we didn't really need to convert, but it's better to play it safe. In this case, both were in micros, so the micros, in a sense, canceled each other. Okay, so dividing gives 1.55 volts. And again, make sure you know the context. The V on the left is the potential. The V on the right is the units of potential, which is volts. Okay, that's our answer. You can always write out the units too. We could write out volts just to make it absolutely clear. Okay, I hope you found this helpful. Let me know in the comments section if you have any questions. Thank you for watching. Please like and subscribe, and I'll see you in the next one.